Welcome viewers. In this video we'll see the classification of power semiconductor devices. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, classification of power semiconductor devices. The first one is power diode. The symbol is given, anode and cathode. We have two terminal, anode and cathode. Silicon controlled rectifier, SCR. We are having three terminals, anode, cathode. In addition, we have gate terminal. By applying the gate pulse, we can control the conduction of this thyristor, the gate pulse. That's why called a silicon controlled rectifier. The third one is static induction thyristor, SITH. So I have anode, cathode and gate terminal is separately available. It's connected through the cathode. Here gate terminal is available at this point. There is a difference. So from this symbol we can identify this is the static induction thyristor. Then the next one is the GTO, gate turn off thyristor. Normally gate terminal used to turn on the thyristor. For turn off purpose, separate process is there called commutation. We cannot turn off automatically. Using commutation we can turn off. But in gate turn off thyristor, both turn on and turn off is possible through the gate terminal. By applying the gate pulse, the thyristor will turn on. By removing the gate pulse, thyristor will turn off. That's why it is called a turn off thyristor. In normal SCR, while applying gate pulse, the thyristor will turn on, but the turn off process is a different commutation process. Right? Once the thyristor is turned on, the gate pulse is removed, not given continuously. But here, while applying gate pulse, turn on, while removing gate pulse, it is turned off. It's another symbol also available. See this, bidirectional. That's why turn on, turn off. That is the indication of the thyristor can be turned on and turned off. That's why this symbol is given. Then mass controlled thyristor, MCT. Right, mass control. This symbol is given. Right, there are two types available, NMCT, PMCT. Right. So here the gate terminal is given in the cathode. Here the gate terminal is given to the anode, connected through the anode. That is the difference. Now we'll see the remaining track and diode. So this is a track. See the two diodes are connected in anti-parallel with the gate terminal. This is MT1, MT2, main terminal 1, main terminal 2. This is a bidirectional device. Conduction on both the direction is possible. That also controlled. Using the gate pulse, we can control the flow of control. Here same thing, here there is no gate pulse. This is also bidirectional device, but there is no control. Main terminal 1, main terminal 2. This will be controllable. Track is controllable. Then we'll go to the power BJT, bipolar junction transistor, power BJT. We know that BJT terminal symbol. We have base, emitter and collector. There are two types available. NPN, the arm are going outside. PNP, arm are going inside. Right? Emitter, base, collector, emitter. Three terminals are available. Then static induction transistor, SIT, static induction transistor. Right? So here the symbol is almost the same as transistor, but the terminals are different. Gate, source and drain, GSD, gate, source, drain are available. Then insulator, IGBT, insulated gate bipolar transistor. Here gate, emitter, collector is available. There is a separate line is given. That is a difference in the IGBT. Now we'll see the MOSFET. This is coming under IGBT. Then we'll go to the MOSFET. So MOSFET, metal oxide semiconductor field effect transistor, MOSFET. The two types available, N channel, P channel. Here we have three terminal, gate, source, drain. Right? So here arrow mark is going inside, N channel, going outside, P channel. So these are all the various types of power semiconductor devices. Now we'll see the classification based on various parameters, turn on, turn off, like that. Various parameters we'll see further classification. What we discussed is classified based on the parameters. The first one based on the turn on and turn off characteristics. The first one is uncontrollable power semiconductor device. There is no control. The example is diode. Once it is turned on, it will conduct. But using like thyristor, we cannot control. So this is uncontrolled. On and off state are not depend on the control signal. They depend on power supply. When the power supply is given, it will turn on. Right? Not supposed based on the gate terminal. And partially controllable power semiconductor devices. SCR, triac and diac. They are turned on by gate signal, but they are turned off by load or line signal. Commutation process. They already we discussed. Only turn on by the gate terminal. Once it is turned on, it will keep on conducting. Gate signal is removed. For turn off purpose, we have to use the commutation process, either load or line signal. That's why it is called a partially controllable. Then fully controllable device is available. Power BJT, MOSFET, IGBT, GTO. Turn on, off by gate signal. When the gate signal is given, turn on. When the gate signal is removed, turned off. That's why called a fully controlled power semiconductor devices. Now we'll go to the next classification. Based on gate signal, pulse gate signal, pulse gate requirement, SCR, GTO, SITH, MCT. Require pulse gate to turn on. Once they are turned on, pulse is removed. Only pulse is enough to turn on these devices. The pulse is given. Another one, continuous gate requirement. We have to give the gate signal continuously in order to maintain in on condition. That is BJT, MOSFET, IGBT. They require continuous signal to keep them in on state. Here only one pulse is enough. Pulse is enough to turn on. Here continuous signal is given. The next one, conduction, current conduction capability. Unidirectional current devices. It will conduct in only one direction. SCR, GTO, BJT, MOSFET, IGBT. Only one direction conduction. Bidirectional current devices. Triac, we already discussed. Triac is a bidirectional. On RCT also. Reverse conducting thyristor. So this is based on the conduction. Based on voltage withstanding ability. Unipolar voltage withstanding. BJT, MOSFET, IGBT. Bipolar voltage withstanding, SCR and GTO. Right. So in this video we discuss classification of power semiconductor devices, various types. Then further classification based on the parameters, turn on, turn off characteristics, gate signal, current conduction, voltage, like that. Further classification also we discuss. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.